Relative motion continued. So I want to tell the story of Timmy, and we've met Timmy before, Daniel, who we once called Super Daniel, and Susie, who we've never met before, but is good friends with the other two. And they go out one day to have some fun. All right. As they're out, there happens to be a coconut tree. Okay? And Timmy, wonderful boy that he is, decides to start walking. Now he happens to start walking towards a bird. We'll get back to the bird in a minute. However, Daniel is afraid of birds. So Daniel runs away from the bird. And Susie just sits and texts with her friends. Because Susie's boring. And that's what boring people do. Okay? Everybody else plays with birds. All right, so let's put in some values here. About Timmy. We always have to measure our motion with respect to things. So I want to assert that the velocity of Timmy with respect to the coconut tree, we're going to label C. We should label up Timmy as T, coconut tree as C, Daniel as D, Susie as S, and the bird. You notice that I've labeled all these things with different letters. Sometimes in the real world, all the things in the real world don't start with different letters. Sometimes you've got Bob and Billy and Bohantu and all these different people that have B names, okay? But maybe you want to talk about Guy or redhead or person with glasses, G, okay? I don't know. Whatever it is, try to make it clear for yourself that these different people are indeed different. Because if you have 4 people that all start with the first letter B, you're going to get confused. I've been very intentional here with my choices. So the velocity of Timmy with respect to the coconut tree, we're going to say is 2.00 meters per second east. And having said east, we really should come up with a reference frame here. I'm going to let east be to the right on our page. I'm even going to let it be positive, and west is negative. Obviously, this is a side view, so I'm not going to make up north. You would be shocked at how many people make up north. You know, if you stand in a spot and jump up and down, you're not jumping to the north. You're jumping up. Okay, this is a side view. So let's not get carried away with always drawing north, south, east, and west. It just happens to the right here is east. All right, so we've got our positive and negative defined. Another piece of information I want to give you, I would like to say that the velocity of Susie with respect to the coconut tree is 0 meters per second. Okay, because she's just a texter.
Exactly 0?
Yep, she's just standing there. Exactly 0. She's not even wobbling at all. And I'd like to say that the velocity of Daniel with respect to Timmy is 5 meters per second west. Oh, I ran out of space. 5 meters per second to the west. Be careful though, that's the velocity of Daniel with respect to Timmy, not the velocity of Daniel with respect to the coconut tree. Okay? So this sounds like a needlessly complicated story, but the velocity of the bird, let's get back to that. Velocity of the bird with respect to Timmy is 7 meters per second east. So lots of information here. I'd like to know what the velocity of Daniel with respect to the coconut tree is. That's my first question. Find the velocity of Daniel with respect to the coconut tree. Oh, that's not really a question mark. but okay, it's a question. Velocity of Daniel with respect to the coconut tree. Now that means that the leading subscript is D and the trailing subscript is C. So whatever I write, velocity of D with respect to C has got to have a velocity D here with respect to something else plus a velocity of, well, something with respect to C if this is going to be a two-vector problem. If it's more than two vectors, then it's going to get more complicated than that. But for this one, I'll let you know it's a two-vector problem. What can I use here? Velocity of what with respect to what plus velocity of what with respect to what is equal to velocity of Daniel with respect to the coconut tree. Can you see it? It's almost an identification thing to start with. Yes, sir?
VDT plus VTC.
Velocity of Daniel with respect to Timmy plus velocity of Timmy with respect to the coconut tree. Yeah, I think that works. We have that information. Okay. So we can sub in some values here. Velocity of Daniel with respect to Timmy, 5 meters per second west, or negative 5 meters per second, plus velocity of Timmy with respect to the coconut tree was 2 meters per second, east, or positive 2. And so we get negative 3 meters per second, or I should say 0.00, or 3.00 meters per second west. In other words, Daniel is going towards the coconut tree at 3 meters per second west. Reasonable. And we can sort of decode things here. What about this one? I want to try to find, I'll try B. I want to find the velocity of Susie with respect to Timmy. Can it be done? I mean, it would require us having velocity of s with respect to something plus the velocity of something with respect to t. Is there such a value there? I can certainly see velocity of s with respect to c being 0. So it could be c. Is there a c with respect to t anywhere? Is there anything close? Yeah, there's t with respect to c, but no c with respect to t. Have you ever been on a maybe at the airport? You know those moving walkways that you stand on at the airport? And if you've never been, you can sort of imagine it. You stand on these moving conveyor belts, basically, to try and get you moving a little bit faster at the airport. And it looks like the whole world is passing you by. And from your reference point, or using you as the reference point, it's like the whole world is in reverse, and you're just standing still. You're like, wow, the whole world is coming to meet me. Aren't I special? That's the way I feel whenever I'm on one of those things. I feel like the whole world is moving past me. And it sort of is true, right? With respect to me, the whole world is just moving along. And so instead of saying velocity of Timmy with respect to the coconut tree, you think it could be valid to talk about the coconut tree's motion with respect to Timmy? Just choose Timmy to be the center of the world for a minute. Or at least the center of the situation for a minute. Velocity of the tree with respect, not Timmy, yeah, there's velocity of the coconut tree with respect to Timmy. Would it be east or west? What do you say, Kevin?
West.
Yeah, it's like the coconut tree is receding into the background. It's almost as if Timmy were standing still, the coconut tree would be traveling west, backwards. So instead of writing velocity of Timmy with respect to the coconut tree as 2 meters per second, what I could write, and it's equally valid, I could say, I'll write it in red actually, the velocity of the coconut tree, notice I've reversed the order of the subscripts. The velocity of the coconut tree with respect to Timmy is 2 meters per second west. Perfectly valid from one perspective, from a specific perspective. So in the perspective where we're considering motion with respect to Timmy. And that's not so bad either. You know, I see these philosopher types sometimes on television, and they talk about reversing the order of perspective on things. So they'll say these really profound things like, is the bird flying through the air, or is the air going past the bird? Oh, deep, right? Well, they'll say things like, do I have a belly button, or does my belly button have a man? Ooh, who owns who here? You know, it can work that, am I walking down the street, or is the street taking me for a walk? And then, they can kind of rope some impressionable young minds into thinking this is philosophy. But it is kind of. It kind of is fairly valid. Is the street taking me for a walk? I guess so. I guess it's slipping out from under my feet at the exact same rate that I happen to be moving my little feet at. You could talk about it that way. Why not? Do I drive my car down New Street? Or does New Street slip out from underneath of my car at the exact same rate that I press the pedal on the gas? All right. Sure.
How do you count?
Now, I'm going to be having a convention in Hamilton next week. If you want to come and give your money, I'll invite you a little bit more, okay? Anyway, so, yes, sir.
But that doesn't work because there's the other cars.
Shh, don't tell anybody. Don't tell anybody. You're right. There is some flaw. There are some flaws in my argument. So if you only consider, it only works if you only consider these two objects, okay? And that's all we're considering is these two objects for the moment. So we can make this statement though. Velocity of Susie with respect to, what do you want to choose? C? I like it. And velocity of C with respect to t, because now we own that value, okay? We can start plugging in our values. 0 meters per second, I know it's 0.00, plus c relative to t, that's 2 meters per second west, and we said west was negative, so minus 2 meters, 2.00, sorry, meters per second. So we can kind of like say that the velocity of Susie relative to the tree, or sorry, to Timmy, I can make it positive west. It's like Susie is like getting pulled towards Timmy. Now, if you only consider these two people, is there any difference between Timmy walking towards Susie or Susie mysteriously sliding towards Timmy as she text messages her friend? Not really, if you consider only these two people, and that's all we're considering. Okay, so the next time you go on a diet or something like that, and somebody says, "Hey, how come you keep on going for the cake?" Well, in a relative motion way of thinking, the cake just keeps on coming for me, right? Like, I mean, it sort of works that way, depending on how you rearrange the subscripts. And that's how you can make your argument with your doctor. "Oh, I'm sorry, I just keep on gaining weight because I keep on switching the subscripts around. The cake keeps on coming straight at me." Maybe it doesn't work after a certain point, okay? But it does work on paper. It does work on paper.